Hey everyone! Ever wondered how WhatsApp delivers your messages instantly? Join me as we explore the architecture behind real-time chat systems.
Let's explore building a real-time chat system like WhatsApp. We'll design for millions of users, focusing on message delivery and low latency. Think about sending a text to a friend, and it arrives almost instantly. How do we make this happen reliably at scale? This video will break down the core architectural components and design choices. At the heart of a chat system lies the need for robust message handling. We need to handle message sending, receiving, and storage, and ensure every message reaches the intended recipient. Imagine a scenario where you have millions of users sending messages concurrently, and how do we manage this huge influx of messages? We'll explore efficient approaches to message processing. A key component is the message queue. Think of it like a postal service, ensuring messages are delivered in the correct order and without loss. This helps in decoupling the sender and receiver, improving system resilience. For more on message queues, check out our dedicated video on Kafka architecture. Message queues are crucial for asynchronous communication. We'll also need a robust database to store messages. Think of it like a digital archive of all conversations. Choosing the right database is critical for performance and scalability. It needs to handle high read and write loads while ensuring data consistency. Relational or NoSQL databases each have their own trade-offs for this use case. We will compare them. Asynchronous processing is vital. It allows immediate acknowledgement of messages while handling tasks later. Think of sending a text versus a phone call. Message queues like RabbitMQ or Kafka decouple components. This ensures that even if one service fails, messages aren't lost, enhancing system resilience. Implementing a caching layer with Redis or Memcached reduces database load. Caching minimizes latency for frequently accessed data, improving user experience significantly. For global reach, consider a content delivery network, CDN. CDNs store chat media closer to users, reducing latency and improving media delivery speeds worldwide. To handle the immense traffic, we'll use Envoy as a reverse proxy and load balancer. It distributes messages efficiently across our servers. Envoy's advanced routing capabilities allow us to dynamically adjust traffic flow based on server health and message priority, ensuring optimal performance. For monitoring, Prometheus gathers metrics from all components. We track message latency, server resource utilization, and error rates to identify bottlenecks quickly. To prevent cascading failures, we implement circuit breaker patterns. If a service becomes unhealthy, the circuit breaker will temporarily halt traffic. To manage this traffic intelligently, we introduce Envoy Proxy, a high-performance proxy mediating all client-server communication. It handles routing, load balancing, and authentication seamlessly. Envoy helps distribute the load across multiple chat servers, preventing any single server from becoming overwhelmed. It also provides observability via detailed metrics. We use Prometheus to collect and analyze these metrics, giving us real-time insights into system performance. We can visualize message latency and connection health. To ensure resilience, we implement a circuit breaker pattern. If a chat server becomes unresponsive, the circuit breaker trips, redirecting traffic elsewhere. Scaling our chat system effectively requires a multi-pronged approach. We need to think about database sharding, connection management, and message routing strategies. Database sharding distributes data across multiple databases. Connection management optimizes how users connect. Message routing ensures messages reach the correct recipients efficiently. Monitoring the chat system is crucial. Key metrics include message latency, connection stability, and error rates. Set up alerts for anomalies. Building a real-time chat system like WhatsApp involves careful architectural decisions. Remember to focus on scalability, reliability, and user experience.
Like, share, and subscribe to my channel for more AI insights. I'm the Code Architect. See you soon.